Now, when it comes to graphing lines, there's more than one way to accomplish this task. What we've looked at so far were examples where we've had to graph by using the function form. However, we don't have to use the function form always. Let's get a couple of definitions. First of all, we ask ourselves, well, what is an X-intercept? An X-intercept is a point where we let the X value, define an X value where Y is equal to 0, right? And we find an X value, right? An X-intercept is a point on a graph where the graph passes through the X-axis. So the X-intercept is a coordinate where the line passes through the X-axis, right? That means it's going to take a point of the form a comma 0. What's a y-intercept? Well, very similar, right? A y-intercept, we find a y-intercept by letting x equal 0 and then finding y. All right, so what do we do with that? Again, same definition except where this line passes through the y-axis. Y-axis here. Let me see if I can spell that in a sort of decent way. And that would be a point like 0 comma b, right? So we call that our y-intercept. Get that a little bit better. All right, 0 comma b. All right, so we've got some point right here. So we're asked graph this equation by using the x and y intercepts. Well, actually, using x and y intercepts are very, very easy. Again, if we want to find a y-intercept, the key is to let x equal 0. Right? Now, if we want to let x equal 0, how do we do it? Well, we use the old business school trick. The old business school trick that I remember was that, well, cover up the term that you're making 0. Right? So we're just going to use our hand here and cover that up. Right? Okay. Well, if we cover that up, right, if we let x equal 0 like we did right here, what's going to happen? Well, that means that our equation now becomes negative 5y equals negative 10. And this is a pretty easy one to solve because we divide both sides by negative 5, divide by negative 5, divide by negative 5, and we get y equals 2. So that means we have the point 0, comma 2 as our y-intercept point. All right, if we want to find the x-intercept, how do we do that? Well, very similar to what we did before right here. We cover up the y-intercept, right, because of the y value, because if we want to find our x-intercept, working here, if we want to find an x-intercept, the key is to let y equal 0. And so if we let y equal 0, that means we now have the equation that looks like 2x equals negative 10. Just like the first one, if we were to plot that, we divide by 2, we've got x equals negative 5. Right, so that means we have the point negative 5, 0 as our coordinate. Okay, so let's take a look at what that's going to do right here. Let's plot those points. We have the points, get this straight here. We have the point negative 5, 0. X-intercept, negative 5, 0. And we have the point 0, 2. Is that what we did? Was that the right one? Well, let's check it out here. Let's see if I can get this graph to do what I want it to do. Look at that. There it is. Exactly right. Now, if you are checking things out, you should, by rights, go through and try and get a third point. What happens? Well, let's see. If we were to let x equal 5, it looks like on this graph, if we let x equal 5, we should get y equals 4. Does that work? Well, we can check that out, right? We can check our work by just making a quick substitution here. Get that pen of work in here. Let's check with the third point. It looks like it passes through 5, 4. Does that work? Well, it should if 2 times 5 minus 5 times 4 equals negative 10. Does it? Well, sure enough, 10 minus 20 does equal negative 10. Everybody goes home happy.